Hello everybody, welcome to Tracy Learning Chemistry videos. Today we'll be discussing about quantum numbers, and in that we'll be covering the practice problems related to how to write electronic configuration of elements. So let's see what all questions we'll be covering in this video. In this video, we'll be writing the electronic configuration of fluorine with atomic number 9 and phosphorus with atomic number 15. Here on the right hand side you can see the energy level diagram of Aufbau principle, and we'll be using the Bohr rule which forms the basis of Aufbau principle, and I've written about the maximum number of electrons and the value of orbitals. So using Bohr rule I'll be writing the electronic configuration. First of all, I will write the principal quantum numbers. Then I will write the orbitals. Now we will fill up the electrons as per the n plus L rule, which is Bohr's rule. In this case there is no more than one orbital, so we will quickly fill up this electrons. S orbital can have maximum of 2 electrons, so I will fill this with 2 electrons. Now in this case n plus L will be 2. Here in this case n plus L will be 3. And in this case again it will be 3. So if I compare 2s and 2p, we will be filling 2s first because it has lower n plus L. So this is 2, and out of 2p and 3s, both of them have same n plus L, but we'll be filling up 2p first because this has lower principal quantum number. So I'll just fill up the leftover. The leftover are 5, and p can accommodate maximum of 6 electrons, so I will write 5 here. So this is the electronic configuration of fluorine as per the Bohr rule. We need not to use 3s, 3p and 3d in this case. Now, in which pattern we should write the electronic configuration? In this case, you can see here that I have written the electronic configuration as per the filling pattern, and here I have written as per the ascending principal quantum number. You can see here in both the cases it's same. So obviously we'll be considering this electronic configuration, that is 1s2, 2s2 and 2p5. But what will be the basis? The basis will be ascending principal quantum number, because principal quantum number, which is n, it determines the main energy shell or the level of an electron, of an atom. So if we consider the reactions or the activity of the electrons like losing, gaining or sharing, it always takes place from the outermost orbit. So we will always consider the ascending principal quantum number as the basis for writing the electronic configuration. So this is the final electronic configuration of fluorine. Now it's time to write the electronic configuration in terms of electronic distribution. For that, we have to consider 2 more principles: the Pauli's exclusion principle and the Hund's rule of maximum multiplicity, that is degenerate rule. So how we will distribute the electrons in the various orbitals? Let's see. First of all, we have 1s2. That means we have 2 electrons. So while we are denoting their electrons, we will use an arrow here. And as per the Pauli's exclusion principle, that in an orbital can have a maximum of 2 electrons only if their spins are opposites. So we cannot place the electrons with same spins. They need to have the opposite spin. So here we have fill in their s orbital. Same goes for the 2s orbital, 2 electrons with opposite spin. Now for orbitals having same energy, we need to apply the Hund's rule of maximum multiplicity, which states that if there are more than 1 orbitals of equal energy, then the electrons will first occupy singly. So in this case we have our total of 5 electrons, so we will fill them singly, that is 1, 2 and 3. After that the pairing will take place, and remember, while pairing we have to follow the Pauli's exclusion principle, that is the electrons with opposite spin. So this is the electronic configuration of fluorine as per the electronic distribution. Now, if you have to write the electronic configuration by using the nearest noble gas electronic configuration, all you have to do is to find out the nearest noble gas configuration. The atomic number of fluorine is 9, so the nearest one is helium. So I will write helium here, which has atomic number 2. So I will cancel 2 electrons, and the rest I will write here, that is 2s2 and 2p5. So this is the electronic configuration of fluorine by using nearest noble gas configuration. Next, the electronic configuration of phosphorus with atomic number 15. Here, first of all, I will write the principal quantum numbers. Then I will write the orbitals, and now I will fill up the electrons as per the n plus L rule. So here we have 2. So out of 2s and 2p, I will fill 2s first, and out of 2p and 3s, I will fill 2p first because it has lower principal quantum number. So this is 6 and this is 2. Now 3 more are left. So we have 3 plus 1, that is 4. Here we have 3 plus 2, that is 5. So the last 3 electrons will go into the 3p orbital, that is 3. So this is the electronic configuration of phosphorus. As discussed earlier, this is the electronic configuration as per the filling pattern, and this is as per the principal quantum number. So we'll be giving preference to the principal quantum number, and this is the appropriate and the final electronic configuration of phosphorus. Now, if we need to write the electronic configuration by mentioning the electronic distribution, then we need to follow 2 more rules: the Pauli's exclusion principle and the Hund's rule of maximum multiplicity, that is degenerate rule. As per the Pauli's exclusion principle, an orbital can have maximum of 2 electrons with opposite spin. So here I am writing the electrons, and as per the Hund's rule of maximum multiplicity, that is, first of all, if we have the orbitals of same energy, then their orbitals are filled with electrons singly, that is with parallel spins, and then the pairing will take place. So here I am filling them. Then again the filling will take place as per these 2 rules. So this is the electronic configuration of phosphorus by showing the electronic distribution. Now, if we need to write the electronic configuration by using the nearest noble gas electronic configuration, then we will choose the nearest noble gas. So in this case it is neon. So I will write neon here with atomic number 10, and I will cut 10 electrons from this configuration. So the leftovers are 3s2 and 3p3. So this is the electronic configuration of phosphorus by taking the nearest noble gas electronic configuration. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.